Hello, good evening. I'm discussing about X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy is a technique for analyzing the chemistry and properties of materials, surface, thin films, and coatings. X-ray photoelectron spectroscopy can determine the elemental composition of the surface elements and their concentrations, along with the empirical formulas of compounds on the surface. The photoelectron process inside the X-ray, the electron is ejected. Ejected photoelectrons have the kinetic energy, H3 minus binding energy minus phi. The work function phi is the detector, is known as the constant. Kinetic energy of the exciting X-ray must be known. X-ray photoelectron is an application of the photoelectric process described by Einstein and was awarded Nobel Prize in 1921, in which electrons are emitted from the atoms in response to the electromagnetic radiation. The principle of X-ray photoelectron spectroscopy is an photoelectric effect where the X-ray are irradiate material causing the electrons to be emitted from the surface by analyzing energy of the emitted electrons. X-ray photoelectrons can reveal the material's elemental composition, chemical state, and electronic environment. X-ray radiation. X-ray are directed to the sample surface. The X-ray energy is absorbed by four-level electrons of atoms within the sample. Photoemission. When the energy of the X-ray is greater than the binding energy of the electrons, the electrons are ejected from the material. These ejected electrons are called photoelectrons. The photoelectric effect ensures that only those electrons close to the surface, typically within the 1 to 10 nanometer, are ejected, making the X-ray photoelectrons a surface-sensitive technique. Kinetic energy measurement. The ejected photoelectrons' kinetic energy is measured using an electron energy analyzer. Binding energy calculation. The binding energy of the ejected electrons calculated using the formula with the energy of the X-ray, E the measured kinetic energy of photoelectron, phi the work function is spectrophotometer constant. Elemental and chemical state identification. The binding energy of the ejected electrons is characteristic of the specific element and the chemical environment of atom. Example, oxidation state, bonding. By comparing the measured binding energy to the known values, the elemental composition and chemical state of the sample can be determined. Instrumentation space, focus beam of the X-ray, and ejected electrodes, that energy analyzer and detector. The main components of the X-ray photoelectrons are the X-rays, ultra-high vacuum chamber with a metal magnetic shielding and electron collection lens, and electrons energy analyzer, electron detector system, and sample introduction chamber, sample mount, sample stage with the ability to heat and cool. And there are several uses of the X-ray photoelectrons. X-ray photoelectrons is used to measure the elemental composition of the surface, top 1 to 12 nanometer usually. The empirical formula of the pure materials, chemical or electronic state of each element in the surface, uniformity of the composition across the top surface, uniformity of elemental composition, is a function of the ion beam depth profiling. Also used in the industries, failure analysis, polymer surface, corrosion, adhesion, semiconductor, dielectric materials, thin film coating. Thanks for watching and thank you for your patience. That's it now. Bye bye.